So yesterday we talked about change in arithmetic sequences. Today we're going to look at the change in geometric sequences. So we still talk about successive terms, one right after another. So for geometric sequences, successive terms have a common ratio. We had a common difference yesterday. We have a common ratio today, which is R. So instead of a constant rate of change, we have a constant proportional change, which means that geometric sequences behave like exponential functions. Okay? It's doubled every time, or we take half of it every time, or whatever. And then it says, except they are not continuous. So just like yesterday, we are not connecting the dots. When you're talking about sequences, you have discrete data, just points, no continuity there. Okay. Then we have two formulas again. And once again, if you're only going to know one of them, the second one is the best one to know. So that's the one I'm going to use for everything. Even if I know that the first one might sort of make it easier, it doesn't make it that much easier. But that way we don't get anything mixed up. I think being consistent is the most important here. So just yesterday we had A sub n because it was arithmetic. Today we have G sub n because it's geometric. So G sub 0 is just your initial value, whatever we're starting with. R, just like we said over here, is your common ratio. And G sub k is your kth term. The little subscripts on the G and the A, that is the term number. So G sub 4 would mean it's the fourth term. So that's what makes it the kth term. Okay. Everybody good so far? All right, so then we have this example here. If we look at this example compared to this form of the formula, then we should be able to figure out a couple of things. What would G sub 0 be? What do you think? If it's in this form. What's in the same spot? 8. And then what is R? 1/2. Okay. All right. And when I go before I go any farther, can I just go ahead and multiply that 8 times the 1/2 to simplify this? That's a hard no. Okay, because let's just think, if I could, why in the world wouldn't they have done that before they gave me the equation? Okay, so that's the first question. But the second thing is, you got to know your order of operations. You have to do your exponent before you can do your multiplication, right? So don't go doing weird things like that. You know better than that. I know you know better than that. So we're going to do a t-chart again. We're going to do n and G sub n. We're going to do 0, 1, 2, 3, and 4. And thank you. So if I want to find G sub 0, that is going to be 8 times 1/2 to the 0 power. What is 1/2 to the 0 power? 1, and then 1 times 8 is 8. That's why your initial term is 8. Because if you don't have anything else in the exponent, like it's not n minus 5 or whatever, then when your n is 0, that's G sub 0. That's why this is your initial value. It'll work every time. All right, so then G sub 1, that is equal to 8 times 1/2 to the first. What is 1/2 to the first power? 1/2. And times 8, that gives me 4. G sub 2 is 8 times 1/2 to the second power. What is 1/2 to the second power? 1/4. And 1/4 times 8 is 2. All right, then G sub 3, 8 times 1/2 to the third. What is 1/2 to the third? 1/8. And 8 times 1/8 is 1. And then G sub 4 is 8 times 1/2 to the fourth. What is 1/2 to the fourth? 16. And 8 times 1/16 is 1/2. So you have to understand how to use exponents, and you have to understand how to use exponents with fractions. You just apply it to the numerator and denominator. It's no big deal. Now, because this is geometric, just like when it was arithmetic and our change in our inputs were by 1, then if our common difference was 3, we could just add 3 each time. Our common ratio is 1/2, so really I'm just taking half of the number before each time. That's how a sequence works. But we're not always going to be looking for them in order. You know, if we need a random G sub 13 and G sub 5 or something, then obviously we don't want to write them all down. But let's graph these. So I got 0, 8, 1, 4, 2, 2, 3, 1, 4, 1/2. Definitely looks like exponential decay, right? Do I connect the dots? No, I do not. No connecting the dots. Everybody good so far? All right. And then these geometric sequences, they behave like what kind of functions? What does it say up there? Exponential. Okay, good. So then when we are looking here, it says for each of the following, determine if the sequence could be geometric. All right, so when I look at A, and I have an equation, is that an exponential equation? No. It has an exponent, right? But to be exponential, the variable has to be in the exponential, or in the exponent. So this is just a quadratic. So this is not geometric. Because it is not exponential. Does that make sense? It's easy enough just to look at that. You could find a table of values and then figure that out. That works too. When you look at B, is B an exponential function? Yes. So then is it a geometric sequence? Yes. So this is geometric. And it says if it's geometric, we have to find the common ratio. So from this, what does R equal? 2. And notice here, that is in parentheses. It's in parentheses here. And the equation they give us, it is not, but it is common and good practice to always put it in parentheses for a couple of reasons. First of all, if this wasn't in parentheses, then it would technically only be 1 to the nth power, because it's not taking the whole fraction. That would just be on the numerator, so that's a problem. So basically for a fraction, it has to be. Here, it wouldn't have to be, but it does kind of help break everything up. And if 2 was negative and I didn't have parentheses, then it would look like subtraction. Like it could get very confusing. So it's just good to put that in parentheses there. All right, so then we look at C. Now with arithmetic, we were looking for a common difference. So if I was doing arithmetic, I would do 3 minus 1 and get 2. But that's not what we're doing. We're checking to see if it's geometric, so I'm looking for a common ratio. And again, the order in which you do this matters. So just like with arithmetic, I do 3 minus 1. If I'm looking for a ratio, I would put 3 over 1, and that would give me 3. And then I do the next 2, and I put 2 over 3, and I get 2/3. And do I have to go any farther? No, because they're not the same. Now, here's what I almost did in second. I caught myself, I think because my little V's were too big. But I did 3 over 1, and then I started to do 6 over 2. And like skip over 2 over 3. Well, look, if I do 3 over 1, that's 3. 6 over 2, that's 3. 12 over 4, 8. You know, so sometimes when you look quickly and you're not thinking about what you're doing, you could easily think, oh, that works. But make sure you're actually using every little successive term. So then here we can just say not geometric. Okay. Not geometric, and your work speaks for itself. All right, so then here, I put -8 over 16. What does that give me? -1/2. Good. And then I put 4 over -8. What does that give me? -1/2. Looks good so far, right? Do I need to keep going? Yes, I do. So -2 over 4 is -1/2. 1 over -2, -1/2. So this is geometric, and we found r already, negative 1/2. Okay. Everybody good so far? Any questions? All right. So then we have example 7. Let G sub n be a geometric sequence, so it's nice that it tells me what it is. They give me a term, they give me the ratio, common ratio, and I'm looking for G sub n, and I'm then going to look for G sub 4. So just like on the other ones, we're going to start by writing our little equation down. G sub n equals G sub k times r to the n minus k power. Now yesterday in the arithmetic, what we had in parentheses was n minus k. So because it was d times n minus k, right? And this is r to the n minus k power. So if you kind of look at their similarities and differences, it kind of helps you remember. You're not really remembering two different things. And then I know when I'm done, G sub n is still going to be in there, and n is going to be in there. I have to replace r, G sub k, and k. So here's my r. They gave me that. And then this is what I'm going to label as my G sub k, because I don't have any other choice, because it's the only thing I got. All right, so then I have G sub n equals, what is G sub k? 12. Good. 12 times r, which is 2, to the n minus, what is k? 1. N minus 1 power. That's your generic, that's what it asks for. Okay? Then we're going to use that to find G sub 4. So G sub 4 is equal to 12 times 2 to the 4 minus 1 power. So that's 12 times 2 to the 3rd power. So am I going to take 24 to the 3rd power? No. Even if you don't know what to do, that's what you don't do, right? So what is 2 to the 3rd power? 8. So that's going to be 12 times 8, which gives me what? Oof, we don't know our multiplication facts, do we? What's 12 times 8? 96. Thank you very much. Here's a quick way to do it since you don't know them. 8 times 10 is 80. 8 times 2 is 16. That's something you can do in your head. Or write that down and just kind of do it quickly and you don't have to. And if you don't, like, if you have this and you don't automatically know, you don't sit there and stare at it. Work it out somehow. Do your 12 times 8 and carry, or whatever you got to do, but do it instead of just staring at it and trying to guess at it in your head, because that doesn't always work out so well. All right, example 8. We have, this is from a graph, and we're going to find an expression for G sub n and use that. So same type of thing, G sub n, G sub 10, but they didn't give me this kind of information this time. They did, they just didn't flat out give it to me. They gave it to me in a graph. So I'm going to write down my formula again. G sub n equals G sub k times r to the n minus k power. Now what I know I need is I need one term and I need the common ratio. And it does not matter which term you use, not at all. But again, you know, why go crazy and use big numbers? I definitely don't want to use these here because I have no idea what that fraction actually is, right? You don't use anything that you're going to have to guess at. This is pretty clear, whoop, right? 0, 8. So that means G sub 0 is 8. The other thing I need is the common ratio. I'm not looking for the slope because it's not a line. But my next point is pretty clear too. My y values are 4 and 8. So to find the common ratio, I use successive terms, like I can't use this one and this one. Got to use 2 next to each other. I put 4 over 8, and that gives me 1/2. Okay? Very straightforward there. We good on all that? So now when I go to write my equation, I have to have, I need a G sub k, so I have that as G sub 0. We're going to make that G sub k. So that means I get G sub n equals, what is G sub k? 8 times r, which is 1/2, to the n, and then it's n minus k. What's k? 0. And n minus 0 is n. So if you put n minus 0, it's fine. It's not wrong, but you don't need to. And really on this one, because I had g sub 0 and I had r, I could have used that first equation. Remember I said let's not even worry about remembering that. If we use that one, it's really just as easy. You just don't have, k is 0 and you end up with that and you're done. So then we are going to find, we're asking for g10. G sub 10, that's going to be 8 times 1/2 to the 10th power. So that gives me 8 times, all right, 1/2 to the 10th power. It's really just 1 over whatever 2 to the 10th power is, right? So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, okay? Because this would most likely be a non-calculator question. You need to be able to take 2 to whatever exponent they want. When I multiply those together, I'm going to get 8 over 1024. So let's say that this is a non-calculator question, and we have to reduce this. One thing you can do is you can take 1024 and divide it by 8, but it might not divide evenly, or even if it does, you might not write your answer correctly then, and I'll tell you what I mean by that when we're done. Those of you that are all anti-fraction, don't let things like this freak you out. I know at one time you were probably taught to find the greatest common multiple, and that's what you want to cancel out, right? And that's fine. There's nothing wrong with that. But sometimes I think you spend longer finding the greatest common multiple than if you just went ahead and did some work. So these are both even. So I'm just going to divide them both by 2. And this is going to give me 4 over 512. They're still even. So I'm just going to go with 2's until I can't anymore. That's going to give me 2 over 256. Still even. So that's going to give me 1 over 128. And then that's my answer. Now, I'm going to show you something else that's not for everybody, okay? And you're going to know if it's for you or not. It's for y'all. It's for those of you that are very mathematical number sense minded. Now, that doesn't mean, like, you can be good at math, you can be very smart, you can love math, and you can be very, very good at it. That doesn't mean that you're number sense minded. It's like the way your brain's wired. So if this isn't for you, it doesn't mean you're dumb. It just means your brain isn't wired that way. But I just want to show you something else that you could do, but only if it totally makes sense to you. And again, those of you that you'll know whether or not it's for you. It's all good. So when we got here, and we have 8 over 1024, we know that 1024, like before I even found it, that's just 2 to the 10th, right? 8 is 2 to what power? The 3rd, right? So then if I reduce that, because they're all multiples of 2, and I know my exponent rules, that gives me 1 over 2 to the 7th. And then that is 2, 4, 8, 16, 32, 64, 128. That's just another way to look at it. And if that type of stuff makes sense to you and you know how to manipulate those numbers in your head real quickly and you're like, oh, I totally get that, then number sense might be your thing. And talk to me later. We'll talk about the math competitions that we have. But if that's not really how your brain is wired, then that's fine too. I mean, that makes sense to me, but that's not necessarily how I would do it. Maybe if the numbers were a lot bigger, but I don't know, this makes more sense to me. But we all good on that? I also want to show you something on the calculator. Now again, I know that y'all have used Desmos a lot, but for some of you, it might have been a year or two since you have even used Desmos at all. Or maybe when you did, you didn't use it a lot. I mean, I don't know where we all are, so I'm just going to remind you of something. If this was a calculator problem, then we could just type in 8 times 1/2. Sorry, I will get faster on this thing once I figure out where all the digits are. 1/2, and then to the 10th power. Okay. So if this was a calculator problem, even if it was, which it probably wouldn't be, but if it was, I can pretty much guarantee you that ain't going to be the answer choice. Okay? Because when we do stuff like this, and it comes out all nicely, it's always in exact form, like the 1 over 128. So if the answer you have actually goes back nicely into a fraction, you should have this little fraction thing here, and you hit that, and it gives it to you in the fraction. Okay? So if you didn't know that, or you didn't remember that, there you go. All right. come back to this for a little bit more in just a minute. All right, any questions about any of this right now? All right, so flip it over. So this is a reminder, which is really a reminder of what was on the front from earlier today. Geometric sequence has successive terms that have a common ratio, not a common difference. This means each term is multiplied by the same number to generate the next term. Okay, just like I said, you could have just taken half of each thing, or you multiply everything by 2, or whatever it is. All right, and then it says that the general form of a geometric sequence is usually the best form to use, and that's what I've already said. Like, just remember that one, and you got one thing to do. Okay. So when I look at this, they've given me everything I need. They've given me G sub 3. They've given me R. I can label that G sub K. So then we're going to write out G sub N equals G sub K times R to the N minus K power. So you take that and the information they gave us, and you write out an equation for G sub N. It's just like what we did on the front. You just substitute and stuff in. That's what I got. G sub n equals negative 3 times 10 to the n minus 3 power. Do we agree with that? Okay, good deal. Then this next one, we've got G sub 2 and R. It's really the same type of thing. And then we want G sub n, and then we're also going to find G sub 5 here. So I would label this as G sub K. So go ahead and, well, let's write this down. We're literally going to write it every time. G sub n equals G sub K times R to the n minus K power. The more you write it down, the more you're going to remember. And then go ahead and find G sub n. Write that equation down. Is that what y'all got? 24 times 1/2 to the n minus 2 power? Yes? All right. So then let's use that to find G5, the fifth term. 5 minus 2. Go ahead and finish that up. What's 1/2 to the third power? 1/8. Good. So 24 times 1/8. And G sub 5 is 3. Okay. We all good look at that? Any questions? So those two just pretty much the same as the front. Kind of what I call plug and chug problems. Like if you know this, they gave you all the information, you just put it in there and just do your thing. You don't. But you have to know this or you can't do any of that. We good? All right, now the next part says, the examples above were relatively quick and easy because we were given one term of the sequence and the value of R. However, how can we deal with problems that give us two terms but not the value of R? Just like yesterday, we had two terms but we didn't have the common difference. We were able to use that to find it and move forward. Kayleen, sit up. And I told you yesterday that the order, like which one's G sub n and which one was A sub n and A sub K did not matter at all. Make it a little bit easier, but here, the most important thing in these instructions is that this says use the larger K value as the G sub n term. Again, you do not have to, but if you don't, you absolutely will be making your life more difficult here. Okay, so I'll remind you how to get that lined up. And then this is just, we're going to go through those steps, but they're listed there if you need them. So when I look at this example, it says, it gives me G sub 3, G sub 6, I need G sub n, and G sub 11. So G sub n is equal to G sub k times r to the n minus k power. Right? That's my generic one. I don't know r, but I have enough information to find it. When I look at these two terms here, okay, I'm looking at the term numbers, which are 3 and 6. I would be shocked if they weren't in order. If they gave you 6 first and then 3, that would just be weird. That's just not the way you write questions, and I don't think they would do that to mess anybody up. So since these little things are in numerical order, then we're going to do our g's in alphabetical order, which means g sub k comes first, g sub n comes second. And once we go through this question, then I'll show you why it makes your life a little bit easier, or a whole lot easier actually. So I can see here that I know g sub n, I know g sub k, don't know r, I'm looking for that, and I know these two, so that's enough to find that. G sub n, 128. What is g sub k? -2, good. I don't know r, that's what I'm looking for. And then what is n? 6 to the 6 minus 3 power. Okay, so I'm trying to get r by itself. This -2 is being multiplied, so I can go ahead and divide it. I'm going to get -64 is equal to r to the 3rd power. How do I undo r? Well, let me just ask you this. To get r by itself, do I divide both sides by 3? No. So even if you don't know what to do, you need to know that that's not it, right? As long as we know that, that's something. Don't divide by 3. I still see that sometimes, but not a lot, but enough to ask. How do I undo a cube? Cube root. So I'm going to take the cube root of both sides, which means r is equal to the cube root of a -64. Now, if I took the square root of a -64, I'd end up with an imaginary number. If I take the cube root, will I end up with an imaginary number? No. Okay, it's totally fine with odd roots. And so there's a couple of different ways we could do it in Desmos. Let me remind you of that. So if let's say I wanted the square root, which I don't, but let's say if I did, I could just type SQRT and I don't have to worry about menus or anything else. But, and there might be another shortcut for this, but I don't know what it is. But you have this little keyboard thing down here, which I'm sure you're very familiar with. So if I click on that, I actually have a square root right there if I wanted to use it, but I'm not going to use that. I'm going to click on functions. I've seen this menu before where I can jump to other things across the top, but then this looks different, so I don't know if they've all been updated or what. But if I scroll all the way down, then I have this nth root here under number theory. So I click on the nth root, and then it's flashing up there where that 3 needs to be for a 3rd root. And then I have my -64, and my answer is -4. Now, honestly, I wouldn't be surprised if this wasn't a calculator problem, and you need to know what the cube root of 64 is. Wouldn't surprise me at all. But there is another way to look at this. So here's just a little side journey real quick. If I have the square root of x, I can rewrite that as x to what power? Do I need to go call your algebra 2 teacher? Okay, 1/2. And then if I have the cube root of x, I can rewrite that as x to what power? 1/3. If I have the 50th root, I can rewrite that as x to the 1/50, right? I mean, it doesn't matter what it is. That's the way it works. So another option you have here, which you don't have to do, but it just, it's your preference, and we have to know that this stuff works anyway. We could say, or r is equal to -64 to the 1/3 power. And if I do it that way, over here, and I do, -64, and then my exponent, and I put 1/3 right there, I get the same thing. But then I don't have to go hunt for menus. So it's just kind of good to know how to do things more than one way sometimes. All right, so now I have r equals -4. Now I need to find the expression for g sub n. So g sub n is equal to. Now, when I'm done, and I'm done writing this, g sub n stays there, and n stays there. which means I don't need this anymore. I needed this to help me find r. I am now going to literally mark it out so I don't accidentally use those numbers. So g sub n equals g sub k, which is negative 2, times r, which is negative 4, to the n minus 3 power. Everybody okay with that? All right, so that's my g sub n. Then I need to find g11. And that is negative 2 times negative 4 to the 11 minus 3 power. All right, 11 minus 3 is what? 8, okay? So that's negative 4 to the 8th power. Now, are we all capable of finding negative 4 to the 8th power? Yes, we're capable. We should be. Do I think this would be a non-calculator question? Probably not. Because nobody's testing, can you multiply big numbers? Like, that's tested at a different level. Do you need to know how to take cube roots? Absolutely. So you having to know what the cube root of 64 is and not have a calculator, I could see that happening on not just a question, just like on anything. But you having to multiply numbers that big, like that's not normally something that's why you wouldn't have a calculator. So I would imagine this probably would be a calculator question. So I want to just remind you of one other thing that doesn't just apply to this, but applies to a lot of things in Desmos. When I type this in, let's see, so that was negative 2 times negative 4. And I usually say, all right, we know that 11 minus 3 is 8. Have we ever subtracted simple numbers wrong? Yes, especially when we're stressed out on a times test and, you know, our brains just don't always work like we expect them to. So we do our exponents. In the calculator, I absolutely would have said, just put in 11 minus 3. Don't put in 8, because just in case, like just be safe. But I want to remind you what happens here. When I type in 11, now notice my cursor is still up here in the exponent. Like it looks like I could just keep typing. The calculator will let you keep typing forever in the exponent. And if you're not paying attention, you're going to be frustrated. But if I just want to do 11 minus 3, when I do minus, it pops it back down there. Now, is that really what I want? That is not what I want. So just again, as a reminder that, and maybe it's not because you're doing 11 minus 3, but if you have to put more than one term in the exponent, it has to be in parentheses. And then you can put whatever you want up there. But, and again, if you're watching what's happening as you're typing, you'll notice that it jumps back down. Just that's how you get it to stay up there if you want to. And then that's your giant number right there, which is G11 equals negative 131, 0, what? 17? So let's think reasonableness of an answer here. Even before I did this, even without doing this by hand, I knew my answer should be negative because I was going to take negative 4 to an even exponent, which makes it positive, right? And then I have a positive number times a negative number, so clearly my answer has to be negative. So that's another little thing you can think, you know, especially if you have to guess or whatever. Okay, we good on that? All right, let's look at this last one. Let G sub n be a geometric sequence. We have, again, 2 of these. We're looking for G sub n and G11. So we're going to write down G sub n equals G sub k times r to the n minus k power. Oh, I know what I was going to show you was the why the order kind of matters here, or what difference it makes if I switch these around. So if I had made this one G sub n and this one G sub k, then these two numbers here would be flipped around, which means my exponent would have been a negative 3. And then I'd have r to the negative 3 power equals something. Then you're going to have to deal with negative exponents. Now, are you always going to be able to avoid negative exponents? No. But if you can do something that helps you avoid them, I would totally do that, just like if you can avoid negative numbers. So that's why that order matters. It just makes your life a lot easier with this stuff. Okay. Anyway, back over here. So same thing. We're going to label these 2 and 7. These are in numerical order. So I'm going to put them in alphabetical order. G sub k, G sub n. And remember, it's the subscripts that I'm looking at, not the actual values. Those could be anything. So then I'm going to have G sub n. Nope, I'm not. What do I substitute in for G sub n? 1.5 equals, what's G sub k? 48 times r, which I don't know. What is n? 7 minus 2. So then I'm going to divide, right? So 1.5 divided by 48 is 1/32. And that's going to equal r to the 5th. So how do I undo r to the 5th? What do I do? Okay, I could use, you mean, where do I multiply by 1/5? In the exponent, right? Okay, just making sure. I don't multiply 1/32 by 1/5, right? That's not what you meant. Like, it could be to the 1/5 power, but I don't multiply this, like, this is not what I do. Okay, yeah, okay. I'm just making sure that, okay, but I could also, but yes, I totally can do that. What's another way to write it? 5th root, right? R equals the 5th root of 1/32, which is also to the 1/5 power, absolutely. Just make sure, because I'm sure I will, because you said what, and I knew what you meant, but I'm not multiplying this by 1/5. Just want to clarify for anybody else that needs to hear that. Now, I can use my calculator, but I also, pretty sure it has something to do with 2's, right? 2, 4, 8, 16, 32. So what's the 5th root of 32? 2. So that means r is equal to 1/2. Or you can put it in the calculator. Because that, if they're going to ask you to use big roots like past cubed, it'll probably be a calculator question. So now I can write my equation. G sub n is equal to, and I'm going to mark these out. G sub k is 48 times r, which is 1/2, to the n minus what? 2 power. Okay, there's my G sub n. Then I want 11. That is 48 times 1/2 to the 11 minus 2 power. Can I multiply 48 by 1/2? No, I cannot. 11 minus 2 is 9. Taking 1/2 to the 9th power is not crazy bad either, but that probably would be a calculator question, so I'm just going to give that to you. That ends up being 3/32. Something you could totally figure out by hand, but what questions do you have? All good? Yes? Alrighty. So remember, you have the assignment already. Yesterday when I gave it to you, I told you only do 7 through 12. Now you can go back and do the 1 through 6, which asks you, is it arithmetic, geometric, or neither? And then the 13 through 18, that's all the geometric stuff. Okay? Any questions at all? Awesome. Once you get that taped in, you can go ahead and get your phones back.